Okay, good morning students. We are back here again with one more new video. In the yesterday's lecture, we had seen the introduction of the chapter Solution and Colligative Properties. So we had started with the new chapter, that is the Solution and Colligative Properties. As per your new syllabus, the chapter is given as the solutions, right? So in today's period, we'll be looking for the types of solutions and how to express the concentration, what are the different methods of expressing the concentration. We'll see the normality and the concept of molarity, right, which are very important concepts. So let's come here. Today's topic, types of solutions. So my dear students, you all have learned the types of a solution in your lower classes in your 8th, 9th, 10th standard, right? So what are the types of a solution? There are total 9 types of a solutions are there. So what are those 9 type of a solutions? So here I will take solute phase and one solvent phase, and here I will take the example. So we'll make a table, right? So let's find out these 9 type of a solutions. Number 1, I am going to keep the solvent phase constant. Let's say the solvent phase is solid and solid. So I am taking the solvent phase constant for 3 times. Why 3 times? Because we have a 3 phases, solid, liquid and gases. So solute I am going to change. So 1, 2, 3. First one will be solid dissolved in solid. See, this is how we are going to say, right? Solid dissolved in solid. Then liquid in solid. Then gas in solid, right? So this becomes the first 3. So what can be example of solid in solid? Brass is the best example of solid in solid. Then liquid in solid, what can be an example of liquid in solid? Liquid in solid will be sugar plus water, that is the best example. Then what can be example of a gas plus solid? Gas plus solid example can be H2 in platinum. That is the example. Okay, now let's see the fourth one. Now I am going to take the solvent as liquid. Liquid, liquid and liquid. Why I am taking it for 3 times? Because we have the 3 number of phases, solid, liquid and gases. So now I am going to change the solute. Solid liquid, then liquid liquid, then gas liquid, right? I hope that you are understanding this. See, solid liquid, liquid liquid and gas liquid. Solid dissolved in liquid, liquid dissolved in liquid and gas dissolved in liquid. So what can be example of a solid and liquid? Here I can take salt plus water. What is the example of liquid and liquid? Ethanol plus H2O, that can be an example of a liquid and liquid. Then what can be an example of a gas and liquid? Gas and liquid can be a moisture, right? So gas dissolved in a liquid can be a moisture. Then 7th one, 8th one and 9th one. Here I am going to change the solvent phase again. So let's say the solvent phase will be gas, gas and gas, right? Now here the solute phase will be solid gas, liquid gas and gas. Now what can be an example of this solid gas? Solid gas का example क्या हो सकता है? Solid gas example can be H2 in PT and liquid gas example can be moisture and gas example can be air, right? So you know these are the examples of the particular solute and solvent mixture, right? So there are how many types of solutions are present? So there are total 9 types of solutions are present. So I request all the students to note down this properly, the types of solutions, right? Okay, now let's move further. Today we will also talk about the concentration of the solution. Concentration of solution. Now what do you mean by a concentration of the solution? See, my dear students, this is a very important concept, concentration of the solution, right? In your 11th standard you had learned this basic concept, but in 12th standard you will learn it in a detail. So what is a concentration? Concentration is nothing but the amount of solute dissolved in solvent is called concentration, right? So remember, it is the amount, it is not the quantity. Try to understand. Concentration of the solution is nothing but the amount of solute dissolved in a solvent is called as the concentration of the solution. Now this particular concentration can be expressed in a three ways. Number one, W by W percentage method, then W by V percentage method, and then V by V percentage method, right? Now in your textbook you will see only two methods are been given. The third method is not given, and today I will give you the third method also, right? And I will explain you the formula in such a way that it will become very easy for you to study and also to make the formula on your own, right? So I hope that you have understood this. Okay, now let's understand what is the significance of this W and what is the significance of this V and W, right? And V and V. So let's take the example first one. W by W method. What does it mean? See, this W, the W which is at the top means a weight of solute, and this W which is at the bottom, that means a weight of solution. Are you understanding it? W by W percentage method. The first W is weight of solute and the second W is weight of solution, not the weight of solvent. Remember this, right? So how we can write, how we can define this? Weight of solute present in 100 gram of solution. 100 gram of solution, right? I hope that you are understanding this. See, W by W. W is nothing but the weight of solute. This W is nothing but the weight of solution. So weight of solute present in 100 gram of solution. Why we are taking 100 gram of solution? As it is the weight of solution, not volume of solution, right? So you have to understand this. Now next is the W by V method, right? Now what is this W? This W is again the weight of solute, and this V is volume of solution. Right? So my dear students, you are understanding it. See, again, this W is the weight of solute, this V is the volume of solution, not the volume of solvent, right? So how you can define this? Weight of solute dissolved in 100 ml of solution. Right? See, try to understand. Here it was 100 gram of solution because it was the weight of solution. Now here, as it is the volume of solution, so we are going to express the volume in ml. Right? We know that we express the volume in a ml. Right? So this becomes the formula or the definition of the W by V. Okay, now let's see the last one, V by V. Now what is this V? This V is nothing but the volume of solute. And what is this V? This V is nothing but the volume of solution. Right? Again, see, again I am telling you, this is the volume of solute, this is the volume of solution, not solvent. So in all the three cases, W by W, W by V and V by V, it will be volume of solution and weight of solutions, right? I hope that you have understood this. Now let's define this. What will be the definition of this? Volume of solute dissolved in 100 ml of solution. 100 ml of solution, right? I hope that you are understanding this. This is very simple method, right? Okay, now let's take for an example and understand this. Let's take the example of a percentage W by W, right? Now let's say that if you have 100 gram of solution, right? You have the 100 gram of solution, and to this 100 gram of a solution, you add a 5 gram of NaCl, right? 100 gram of a solution you have, and to this you have added the 5 gram of a NaCl. What do you need to calculate? You need to calculate percentage W by W. What is the percentage W by W? Right? How you will calculate? So here, what is the weight of the solute? Weight of the solute is 5 gram, right? So 5 divided by 100, right? 5 divided by 100, it will be equals to into 100. As we are going to calculate the percentage, so we all know that the percentage will be calculated in terms of 100. So it will be 1 molar, right? It will be 1 molar, or we can say the answer will be equals to, 5% W by W, right? It will be 5% W by W. I hope that you have understood this, right? 5 divided by 100, as we are calculating it into 100%, so it will be 5% W by W. Okay, now let's move further. Representation of formula. So how we are going to represent the formula? So in this case, we are going to represent the formula by using this particular notation, right? So W by W. What does the W by W? It is very easy to represent the formula. W means weight of a solute. Weight of solute divided by, what is the second symbol? Weight of solution into 100. As I told you, we are supposed to calculate the percentage in 100, so that is why it will be into 100. So what will be the formula for percentage W by V? Weight of solute divided by volume of solution, right? It will be volume of solution into 100, right? And here next it will be percentage V by V. It will be volume of solute divided by volume of solution. So in all the three cases you can see volume of solution and weight of solution. So there is no involvement of the solvent. Again it will be into 100, right? So this particular formula is very, very important. You should know all this formula and how to express the particular concentration, right? I hope that you have understood this. Okay, now let's move further. Now let's understand the concept of molarity. So what is exactly molarity? Right? So my dear students, since your childhood days you might have learned, since your 7th, 8th, 9th standard you might have learned about the concept molarity and the normality, as well as the molality and mole fraction, right? So here we are going to learn this again, right? It is a very, very important concept, molarity, right? So what is molarity? Molarity is nothing but the total number of moles of solute dissolved in 1 liter of solution, right? This is what is called as the molarity, the total number of moles of solute dissolved in a 1 liter of solution, that is said to be the molarity. See, here I am talking about the moles, right? The mole concept is very, very important. This particular concept also you people have learned in your earlier classes, right? You should know how to calculate the moles. Until and unless you know how to calculate the moles, you will not be able to calculate the molarity and the normality. So how to calculate the moles? Moles is equals to weight of a substance divided by molecular weight, that is your calculation of a moles, right? So if you don't know how to calculate the moles, note down the formula. Moles is equals to weight of the substance divided by the molecular weight, right? I hope that you have understood this. Okay, now one more thing. Molarity is always expressed in terms of mole per dm cube. Mole per dm cube, right? Always remember it is expressed in terms of mole per dm cube, right? And molarity is represented by capital M. Always remember, molarity is represented by the capital M. Molarity is always expressed in terms of mole per dm cube, right? So I hope that you have understood this. Now let's see the formula of the molarity. Formula is very simple. Molarity equals to number of moles of solute divided by volume of solution in dm cube, right? So this is the molarity. Now we can write the another formula in a simple way. We can say M is equals to capital M is equals to small n by V, where M is nothing but the capital M is nothing but the molarity, N is nothing but the number of moles of solute, and V is nothing but the volume of solution, right? It is the volume of solution, right? I hope that you have understood the concept of molarity. So what is molarity? Molarity is nothing but the number of moles of solute dissolved in per liter of solution, right? Okay, now here we can take one example and let's understand this. We'll take one example of molarity. For example, let's say we have 500 gram of solution and 20 gram of NaOH is added to it, right? We have a 500 gram of solution and 20 gram of NaOH is added to it. Then what is the molarity? What is the molarity of NaOH? Right? So in this case, how to calculate this? See, in order to calculate this, as I told you, you should know the concept of mole. Until and unless you know how to calculate the total number of moles present in NaOH, you will not be able to calculate the molarity. Now let's first calculate the mole. So here in this case, what will be the molecular weight of NaOH? The molecular weight of NaOH is 40, right? The molecular weight is 40. What is the given weight? Right? Given weight of a solute is 20 grams. See, 20 gram is given, right? Now will it be able to calculate the total number of moles? Yes, we can calculate the total number of moles. So moles is equals to weight of a substance divided by molecular weight. So moles is equals to, what is the weight of the substance given? That is 20. Molecular weight 40, right? So what will be? It will be 1 by 2, that means is equals to 0.5. Agar therefore for 500 ml it is 0.5 molar, right? Then therefore 1000 ml it will be 1 molar, right? Are you understanding it? Why 1000 ml? Because what is the molarity? Molarity is nothing but the number of moles of solute dissolved in 1 liter of solution, right? Whenever we talk about the 1 liter is equals to 1000 ml. So we always express the molarity in the 1000 ml or 1 liter solution, right? So 1000 ml ke liye it will be 1 molar, right? So that is why I tell you that mole concept is very important in order to calculate the molarity or the normality, right? So it is enough for today. I hope that my dear students you have understood the concept. So tomorrow we will come with a new concept, that is the mole fraction, normality, and we will see that in the next period. Thank you very much.